Okay, now we get into what we call networking. Okay, so what is networking? We will look at what we call network crashing. Okay, so network crashing looks at the duration it will take. Okay, so duration it to take. Oh, just a minute. Okay, so it will look at the duration that the project will take to complete, how long the project would take to complete. Okay, so um, under networking, we are talking about finding what? Okay, so for this one, we're talking about um, calculating the what project duration. So we have the project duration. It means how long it will take for us to finish working on this project, which is also called the critical path or the critical times. We have these as critical times. Okay, so that's what we know we do. So we crash activities. So we always crash activities on the critical path in order to reduce project completion time. So we always crash activities. So what we do now, we should obtain an activity table to obtain activity table. So we should obtain an activity table where we have the cost difference. So cost what? Cost difference. Crash limit. So the crash limit and the cost per day. So these are the three things that an activity table will consist of. So when you get an activity table, you should expect to have these one: the cost difference, the crash limit, and the cost per day. So cost per day, where cost per day is equal to cost difference, cost difference so cost difference you divide by crash limit. So cost difference divided by the crash limit. This is the cost per day. Then how would you find the cost difference? Cost difference is equal to crash cost minus normal cost. Crash cost minus the normal cost. And then, of course, the crash limit is equal to normal time minus the crash time. Normal time minus the crash time. So this is on the aspect of the crash limit. Okay, so this is what networking and project crashing is all about. Okay, so project network crashing. So you look at the project duration or critical times. We always crash. So this is number one. Number two, we always crash activities of the critical path in order to reduce project completion, project time. We obtain activity table, which has the cost difference, the crash limit, and the cost per day. Cost per day is equal to cost difference divided by the crash limit. Then cost difference is equal to crash cost minus normal cost. Then crash limit is equal to normal time minus the crash time. All right, so that getting down to this question. Okay, so this question says, consider the data of a project as shown in the following table. We have the activities 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 3 to 6, 4 to 6, 5 to 7, 6 to 7. These are the normal times. These are the normal costs, the crash times, and the crash cost. Okay, so those are the ones that we have. So if the indirect cost per week is 200, indirect cost per week is 200, all right, find the optimal crushed project completion time. Okay, so find the optimal crushed project completion time. All right, so what happens here is that first and foremost, we draw the network diagram. So network diagram, we are simply saying the diagram comes this way, 1 to 2, 1 to 3, 1 to 4. So 1 to 2, 1 to 3, 1 to 4. So this is what we have. Then 1 to 2, the duration is 7. 1 to 2, the duration is 7 here. Okay, these are the durations. 1 to 2, the duration is that. The normal time, 5 and 8, just put there. Okay, then we move on to the other ones. Other ones are 2 to 5. So 2 to 5, 3 to 5, and 3 to 6. So 2 to 5, 3 to 5. Okay, so 2 to 5, 3 to 5, and 3 to 6. From here, 2 to 5, 3 to 5, 3 to 6. Those ones. And of course, now we get into 4 to 6. So get into 4 to 6. Okay, 4 to 6, 5 to 7, 4 to 6, 5 to 7, 4 to 6, 5 to 7, then 6 to 7. Okay, so 6 to 7. All right, 6 to 7. So the durations are these ones. So 6 to 7. These are the durations. All right, so we allocate there. That's the first thing to do. We put the durations there. So that is a network diagram, which is this one here. Okay. So the various routes, you can move like 1 to 2, go this way to 7, 1 to 2, 2 to 5, 5 to 7, from this point to the other point. All right. So here we are going to have 18. And the other one is 1 to 3, 1 to 3, 3 to 5, 5 to 7, 1 to 3, 3 to 5, 5 to 7 is 12. So as this one goes, then the other route will be 1 to 3, 3 to 6, 6 to 7, which is giving us 14. These are the activities. Then the other one will be 1 to 4, 4 to 6, 6 to 7. Okay. So this is about what is happening concerning the network diagram. All right, for those who are just joining in, please, we are looking at the network project crashing, where we are simply looking at, in the networking, we look at project durations and the critical activities. We always crash activities of the critical path in order to reduce the project completion time. Okay. And then we'll need to obtain an activity table. The activity table looks at the cost difference, the crash limit, and the cost per day. So the cost per day is equal to cost difference over the crash limit, and the cost difference is equal to crash cost minus the normal cost. So the crash limit is normal time minus the crash time. This is how you get the crash limit. The cost difference is crash cost minus the normal cost. Okay. And the cost per day is cost difference over crash limit. Okay, so activity table should have comprised of cost difference, the crash limits, the cost per day. All right, so this is what network crashing is all about. So the network diagram is obtained from the information given in the question. Like I mentioned, we have 1 to 2, 1 to 3, 1 to 4. So this is obtained in this way. So 1 to 2, 1 to 3, 1 to 4. Okay, and so we are putting the respective durations or normal times. Then we have 2 to 5, 3 to 5, 3 to 6. So 2 to 5, 3 to 5, and 3 to 6. Okay. So 2 to 5, 3 to 5, 3 to 6. Then also we have 4 to 6. So 4 to 6 is 7 there. All right. And the other one that we need to look at is 5 to 7, 6 to 7. So 5 to 7, 6 to 7. And you get the respective what? Due date. Respective date durations 5 to 7 and 6 to 7. Finding the various routes from point 1 up to the other point. So the various routes we can talk about, the first route we can talk about is this route, this one, and that one. The other one will be this one, and this one. Then the other one will be, okay, this one, and this one. And the last route will be this one. Okay. So this is what goes on. So the critical activity here, there are two critical paths, 18 and 18. So you obtain two critical routes. So activity, you have the crash limits using the formula to get the crash limit. We said our crash limit is equal to normal time minus the crash time. Normal time minus the crash time. This is how you get the crash limit. Normal time minus the crash time. That's how you get the crash limit. So you're subtracting the normal times and the crash times. So the normal times, so the crash limit is just the difference between the normal time and the crash time. So you have the normal time minus the crash time. So the limit here is the difference between 7 and 4, which is giving us crash limit of 3. So the crash limit of 3. So this is how the crash limits were obtained. Then the cost difference, like I mentioned, is equal to crash cost minus the normal cost. Crash cost minus the normal cost. Crash cost minus the normal cost. Okay, so that's how you get the aspect of okay, the aspect of the aspect of the cost difference. So from here now, we crush activities or critical path in order to reduce the project completion time. That's simply saying the 18 weeks is too much a time. So we need to reduce the project completion time to a lower time. So the total cost of this project, you just simply first and foremost add the normal cost of the entire project. So the normal cost of the entire project is this one. Okay, before you consider the indirect cost of 200. So it's a 700 plus a 500 plus a 600 plus 800 plus 700 plus 1 plus 1 2 plus 400 plus 500. So it's the total cost here. It is actually a TC. Okay, so the total cost of this one is actually 65. Okay, so 65 is the total cost. So from this 65, you now incorporate the indirect cost of 200 per week. So 200 per week, we incorporate it. So meaning that the total cost came to 65 plus 18 times 200. So it's giving us 10,100. So we usually crush activities on a critical path with the lowest cost there. Okay, so this is our supposed to crush activity 1 to 2 and 4 to 6 by 2 weeks. Okay, so the two critical routes are which ones? The two critical routes are, you identify them here, 1 to 2, 1 to 2, 2 to 5, and 5 to 7. 1 to 2, 2 to 5, and 5 to 7. Okay. So when you come here, the critical routes are 1 to 2, 2 to 5, and 5 to 7. Then the other route that was critical is 1 to 4, 1 to 4, 4 to 6, 6 to 7. 1 to 4. All right, so 1 to 4, which is this one, 4 to 6, and 6 to 7. So you check the one that has the least cost per day. So the cost per day is just dividing the cost difference divided by the crash limit. So this one is dividing by 3, by this one by 2, dividing those one to get the cost per week. All right, so now we get down to, so the one that has the least cost per day for these two is going to crash them simultaneously. So this one is 50 from this activity, considering this one. Okay, so considering okay, so considering this one, and this one. So the one that has the least cost per day is actually 50 from this other route. Okay, so there's a 50 to 25 as well as 100. So a 50 is the least cost per day. So we're just crashing activities on the critical path with the smallest cost per day. So all these two critical routes are supposed to remain critical until you finish crashing. So that's why here we crash activity 1 to 2 and 4 to 6. Because 4 to 6 from this other end, they are the ones that had the least cost per day. So this other one, it was a 200, 125, and 350. So we're supposed to crash these activities simultaneously, and they reduce the project completion time. So here, we're crashing 1 to 2 and 4 to 6 by 2 weeks. So we got the duration changed. Okay. So these numbers we're just adding 0 plus 5 to get 5 on top there. 5 plus 9 is 14. So we're just confirming how the durations are reducing. Right. And then what we are doing now here is that we are saying that the project completion time has now reduced to 16 weeks. So 16 weeks. And then what's the total cost now? There was a 6.5. So 6.5 as it were, which was the normal cost initially. Then plus how much we have crashed. We have crashed this 1 to 2 by 2 weeks. 2 to 4, we crashed it by also 2, and it at a cost of 125. So 125 here. Then we are remaining with 16 weeks. So 16 weeks multiplied by 200. 16 times 200. Then plus 100 plus 125 by 2. All right. Then plus a 6.5. So you're getting 10,050. So the cost is 10,050 now. But the limit for 1 to 2 is a 3. So we still have a pending day to crash. So that's why we can't move on anywhere. So we are going to crash now activity 1 to 2. Another attempt 1 to 2 and 1 to 4. Since this one we have exhausted. Okay, 1 to 2 and 1 to 4. So this one is done. So 1 to 2, we're crashing. We're looking at these two routes. We're crashing them simultaneously, but we should consider the crash limits. If we have crashed 1 to 2 and we are done, that's when we can go to another activity to crash. So we're going to crash activity 1 to 2 and 1 to 4 by 1 week. Okay, because here we have moved away from 4 to 6. All right. So this is what's happening. So after crashing by these weeks, you can see you're selecting so that the crash limits we're using are these numbers here. So these numbers are the numbers we're using to crash. These are limits that we're using to crash. Should we exhaust crashing? So meaning we should have, well, for us to stop crashing, we should crash 1 to 2 by 3. All right. And of course, 2 to 5 by 2 and 5 to 7 by 1. So meaning 3 plus 2. Okay. Then plus 1. 3 plus 2 plus 1 is 6. So meaning that as we finish crashing, the total number of weeks that we were supposed to remain here with, it will be, okay, 13 weeks. Okay, that was the total crashed time for this project. Okay. All right, so we're crashing 1 to 2 and 1 to 4 by 1 week. Okay, so meaning 1 to 2, we crashed it by 2 area. meaning that there's a pending day. That's why we cannot go to another activity to crash. What it means is that we should crash these activities, the 1 to 2, 2 to 5, and 5 to 7. When we crash them by their limits, that's when we can only stop crashing these activities. All right. Okay, so we are crashing now 1 to 2 and 1 to 4 by 1 week. So the project remained as 15 days now, 15 from 16. It is reducing. Okay, reducing was 16. Initially it was 18 days, 18. We have crashed by 2, came to 16. From 16, it is going down to 15. But of course, we take note of what is happening. So this cost, okay, so this cost here, okay, this cost, okay, so this cost of 10,050, you keep on incorporating it. All right. So that cost keeps on, we could keep on incorporating it. As we incorporate that cost, you see what is happening. So you carry forward 10,050 comes here. 10,050, then after crashing these ones by the respective crash limit of 1 week, then it's giving us, but we multiply by the respective cost, so we are getting down to 13,300. Okay, from the 15 days, we are crashing activity 1 to 4 and 5 to 7 by 1 week. 5 to 7 at the 1 week here, so we're crashing them simultaneously. 5 to 7 1 week, and of course crashing which other one? Crashing 1 to 4, 1 to 4 here. We're crashing these ones simultaneously. So we're crashing these ones simultaneously. So we are getting now the value as 13,300. Okay. So after that, we moved on to crash activity 5 to 7 and 1 to 4 by 1 week, where we are now getting, you multiply these ones by the respective crash limits. Okay, you're looking at the cost per day. So if you're crashing by 1 week, your cost per week. So if you're crashing by 1 week, you multiply the cost per week by the crash limits, by how much you are crashing by. So if you are crashing 1 to 4 by 3, you multiply 200 by 3. If you are crashing by 1, multiply 200 by 1. So this is how we got 13,300. Then moving on to the other aspect now. Okay, so the other aspect is it where we now crash activity 1 to 4, 2 to 5, and 1 to 3 by 1 week. We got 13. Okay, so 13 what? 13 weeks. So the total cost was 16,200. This is the cost of this crashed project. So the cost of this crashed project is 16,200. Okay, so 16,200 is the cost of this crashed what? Project. Because the question was asking us that, okay, what is the cost of find the indirect cost is 200 per week, find the optimal crashed project completion time. Okay, so the total cost of this project after being crashed, looking at this activity table, is actually giving us 16,200, right, from the the cost that we are actually getting. Okay, so this is it, what goes on here. All right. Excuse me, I know you joined a little bit late, Mr. Kennedy. Okay, so we end here for now.